Now for that token, I mentioned that it would be a string in the end which we generate, which is generated with the help of a certain private key and a certain algorithm. And then we can encode data into that string. So we can, for example, encode the user ID that belongs to the token into that token. You won't be able to read it directly in the token, but you can then decode the token to find out which data is in there, for example. So to create such a token, we'll install another third-party package. And this package is called JSON Web Token. One word, and simply install it with npm install -- save. This is a package which allows us to generate such tokens with that private key. And therefore, here in user's controller, where I want to generate such a token, I will import it and store it in a JWT constant and import it with required JSON Web Token. Of course, you can name these constants here whatever you want. Let's restart the server with npm start thereafter, and now we can adjust our code. And I want to generate such a token both for sign up, because if a user is signed up, I know that this is a valid user because, well, we just created the user. So we can also create a token there. And of course, I also want to generate a token for login. So let's start with sign up. Here, we're storing a user in the database so thereafter we know this is a valid user. And now we can generate such a token. And it's thereafter actually the token and maybe some user data which I want to return instead of the entire user object, because not all user data is directly required in the front end here. But that of course depends on the application you're building and your exact requirements. So here I will add a token variable, and then to create it, we can call JWT, so this package I just added, sign. The sign method here returns a string in the end, and this string will be the token. So we can actually say token equals JWT sign, and then it takes some arguments, some inputs. The first argument here is the payload of the token, so the data you want to encode into the token. And this can be a string, an object, or a buffer. Now here I will encode an object, and the entire serialization and encoding logic will be handled by this package. So here we have a vanilla JavaScript object, and there I want to encode the user ID into the token so that we know which user this token belongs to. And for that I will use my created user .id. ID is a getter provided by Mongoose on every created user document object we're working with, and this is the ID MongoDB will have generated for this user. And maybe we also want to encode the email address, but it's up to you which data you want to store here. I just chose some examples. So here I'm encoding the user ID, which is very important in my case, and the email into the token. The next argument here is this private key. So this simply is a string which only the server knows, so which you never ever share with any client. It's only in your server-side code. And here I will name this super secret don't share. And of course you can enter any string you want here. The last argument is optional, and here you can configure the token with a JavaScript object where you can set up certain options. For example, you can set a token expiration with expires in, and this accepts terms like 1 hour like this. You can check out the official docs of JSON Web Token to find all information about all config options here and about all the time strings you can pass to expires in. Now, letting the token expire is actually a really recommended practice because the token we send back can't be faked or edited by the client, because whenever you would do so, since you don't know the private key, you would generate an invalid token. So even if you decode it on the front end and you tweak the user ID and try to recreate the token, you won't be able to replicate this token because you don't know the private key on the client. So that is how we secure the token. But if you steal this exact token we're generating here, if someone gets access to your token, then this token is enough to fake that this person is you, because this token is accepted by the server as your identity, so to say. It's accepted as your I am logged in proof. Now, stealing that token on the client is a different thing. It's not that easy, and I will talk about this when we actually store it on the client. So it's not that easy to steal that token. Still, as an extra security mechanism, it is recommended that you let this token expire, for example, in an hour, so that even if it would be stolen, there only is a very short time duration during which attackers could do something with it. Now, this token creation also could fail, so I will wrap it with try catch here. It doesn't return a promise, but it still could fail. So here, try catch, and if it does fail, I will just return my signing up failed error here. If it does not fail, however, we do have a token, and therefore now I can return this as part of the data I want to send back. Now, the data I want to send back totally is up to you. Here, for this user sign up process, I will send back the ID of the user that was created, which I get from created user ID, the email maybe, which is created user.email, and very important, this token. These are the 3 pieces of data I want to return here, but again, it's typically up to you what you want to return to your frontend in the application you're building. Now that was the sign up process. Let's repeat this for the login, and of course feel free to pause the video at this point and try this on your own. After a short pause, which I give you to pause the video, we'll do it together. So, were you successful? Of course, it shouldn't be too hard. We can just copy this token creation code here and go to the login process here. And once we validated that we do have a user for this email address, and once we also validated that the password is correct, so right before we send the response, we want to generate this token. Now, important, use the same private key as above. If you use a different one, you will generate different tokens. And therefore, when the client later sends a token with a request, you wouldn't be able to validate them correctly on the server. And here this should be logging in, I guess. So make sure that you use the same key here in login as you did in sign up. I will also use the same expiration date, of course. In general, I want to have the same configuration for my token. Just the data I encode is generally the same, but here in login, I don't have the created user. Instead, we have the existing user here. So I get my ID, which I want to encode from existing user ID, and the email from existing user email. Other than that, it's the same logic. Just the error message changes to logging in failed. And then here, as a response, I don't return a message. I don't return the user object. Instead, I return the user ID, which I get from existing user ID. Maybe also the email, which we get from existing user email, and very important, of course, the token, which we just generated. And with that data, the client, so in our case, the React application, will be able to use and store this token and attach it to future requests to routes on the backend that require authentication. And that is actually the next step. We are generating this token, but thus far it's totally useless. Thus far on the client we could store it or we could not store it, because besides this token generation, we haven't added any logic to the backend that would protect certain routes from unauthenticated access. Right now you still can send any request to any route here. We're not blocking this. So as a next step, we want to make sure that certain routes, like creating a new place or patching or deleting it, are only accessible if the request has a token attached to it, and this token also is validated by the server, and we can confirm that it was created with this private key. So as a next step, we'll implement this route protection on the backend.